Alright, good evening everyone. This is Obi-Wan Pez for Ensimplex Pachinko. We are looking at doing some math tonight. And if anybody has any questions, feel free to ask. There we go. Lost my pen for a minute. Kiwi Gamer, I'm really sorry you're dealing with mold. I know that's never fun. Our school had portable trailers which had black mold in them, and they were like instantaneously, as soon as they found it out and got it tested, they were like, yep, okay, they're condemned. If it's like black mold, yeah, it's not good. Yeah, it's not quite, I'm not sure it's toxic, but like, yeah, it's not good. It causes all sorts of health problems. Can generally start like bothering people's allergies is kind of the first thing. But if nobody in the house actually is bothered by it, then that becomes a bigger issue, because then you can have like respiratory problems, asthma, all sorts of stuff, because your body's trying to fight it. Ah. Yeah, yeah, yeah. Oh yeah. Those little fungus, teeny tiny little mushrooms, essentially. That are, yeah, if you have watched any of my, yep. If you have watched any of my control streams, that is a little bit, of an extreme case, but, same basic idea there. Our AC, apparently, is not working again, at least not properly. So we're pretty sure it's a leak in the old system, in like the old pipes that are still in the walls. So they have been leaking refrigerant. So that's also a curiosity, like, have we been breathing that stuff in? Is it leaking outside? I hope, I hope. Because if not, that would not be good. Mm-hmm. Yeah, it's really hard to tell like what could be the problem uh, with that versus like, is it just something that you've had for a long time? I know, for instance, that I have had this really, I mean, anybody who has been here has seen it. I have a rather progressive cough, which just keeps coming, no matter what I do. And it got really a lot better this past year because I didn't get sick with anything. It was still there, but it was a lot better than when, I have a cold and it's just all the sinuses are doing bad things. So, and there we go. 1 second here. Yeah, cheese is fun. Randomly popping back in. Don't mind me. Alright, so for today, I thought we'd deviate just a little bit. Instead of going to Calc 2 yet again, might do a little bit of work in number theory just for fun to figure out yeah, to figure out just some problems that are here, try to get practice problems, you know, get some practice solving number theory type problems. And this, I think, showcases a little bit more of like, let's figure out how to solve stuff. Very nice. Yep, differential calculus is not a humongous section, although the applications take up, you know, most of your book. So, yeah, I really liked the implicit differentiation. It is partly like a simplification of Calc 3 is really what they're doing. Um, so I actually had a a grad student when I was an undergrad at the University of New Hampshire, where they were trying to figure out the derivative function for function that did this. Now, granted, it is supposed to be symmetric, so like roughly something like that. This is supposed to be nicer and rounder and more circular, but whatever, it's fine. I don't suppose Desmos is actually going to let me graph that. At least not easily. Yeah, okay. It will actually let me graph that. So I just can't figure out what the exact actual equation of this particular function is. So it's been too long. How do you guys get good at integrals and stuff? So that is an interesting question unto itself. How do we get good at anything really is a whole lot of practice. And reminding ourselves what individual rules are, and then as you start building out further, it allows us to, you know, build a framework, which then we scaffold to make better and bigger assumptions, clarifications, all sorts of cool stuff like that. Now, if you mean like, how do you formulate the integral from, like, let's say we wanted to figure out the area under a certain curve, whatever this might be, you know, provided that we have a function for this. So f of x is equal to, let's say, it's going to be slightly variable. So 1 over x, that's going to be cosine of x yeah, give or take. So if we do something like this, cosine of x over x plus 1, and we want to figure out what the integral is for this particular function, right? Like, this is not going to be a nice one, I don't think. There's the possibility here that this is not going to be solvable by any means, but we'll give it a shot anyway. So by the fundamental theorem of calculus, we want to know what function has this as its derivative. So my first go-to for something like this, this is probably a terrible mistake and I'll regret it instantly, but my first instinct on this one would be to do like integration by parts. So there's this property which I talked about last time. The integral of some function u times some function dv is going to be equal to u times v minus integral of v du. And in one of my previous Wednesday night thingies, we had actually shown that this is the same as integral of u dv plus integral of v du is equal to uv, which is equal to, if we take the derivative of this thing, then we're taking the derivative of each of these things here, which end up knocking out the integrals. And making u dv plus v du, or u v prime plus v u prime is equal to parentheses uv all prime. So this is basically just the product rule. It's reformulated a little bit, but it's the product rule. So integration by parts is the product rule, and you can use it to solve integrals that are more difficult. And again, integral is just a way of saying what is the antiderivative, specifically the indefinite integral like this one. So anything with just the integral sign and no numbers on it is just saying what is the antiderivative, or what function would get this as this stuff on the inside as the derivative. Now for all this stuff, really, you'd be probably looking at the product rule and saying, okay, it's u times v all prime. It's going to get you this stuff over here, or just uv is equal to these two integrals summed together. So, yeah, and because... Sorry, if L'Hopital's rule works with differentiation, does it work with integration at limits at infinity? So... Maybe. I don't think technically it does, because I think that there is some issue with the possibility that, well, you're doing it as the limit, right? So L'Hopital's rule, just using this stuff. there's nothing here, so I'm guessing that there isn't really a way to do it. I see what you mean, though. Like, if we could just take L'Hopital's rule and literally reverse it. So, like, if we had the limit of f prime at x over g prime at x for some x approaching c, whatever it might be, then this by itself should then therefore be equal to taking the limit as x approaches c of f of x over g of x. And therefore, if f prime and g prime were u at x and v at x, then this would mean that we have the limit as x approaches c of, nope, not f, u at x over v at x like this, right? When we do the capitals, typically we refer to those as the integrals, where u of x equals the integral of u of x dx, and v of x is equal to the integral of little v of x dx. So like this should work technically, but then we also have to think about, well, it could be that when you reverse this, it doesn't actually work. I'm trying to think of a reason or a counterexample which would make it not work, but you know, I'm coming up blank just because you know, we're on, it's kind of on the spot or whatever, but it's fine, don't worry about it. But yeah, it's an interesting idea. Does this actually work if we were to reverse this? I think there could be a potential problem in that your plus c may not technically matter unless, for some reason, the c at the end is the highest degree term. So if you had like stuff that was you know, 1 over x or 1 over x squared or you know, 1 over cosine or anything like that, and then you had this plus c, the plus c would end up being the highest degree term, or the highest term in the hierarchy of functions. And so if you had it as the highest term in the hierarchy of functions, then it is driving everything. So having a plus c on the top and then having like a plus d or c2 or whatever you want to call it on the bottom could potentially drive the entire rest of the ratio. It kind of all depends. Well, if you had a zero function, that kind of messes up everything anyway, but zero functions always mess up everything. Intentionally messing stuff up. I mean, if you want to prove that it doesn't work, then yeah, potentially. But then you also have to think about, like, generally, does this work, or is it just like under some special cases? I see you lurking there, sir. Thank you very much for coming in. I'm not going to call you out. After integral calc, I have logic and proof. Yep, nice. And an analysis book. Nice. So yeah, the logic and proof course that we do for our undergraduate is, let's see, that was my 531, so that's not written for beauty but for efficiency. That is also very true. Yeah, we had that one, oh man. There was that one class, abstract algebra, which ended up being like, oh, hey, we're going to, we're gonna throw you in on the deep end and say, like, okay, you have to prove the entire series of mathematics, the entire structure of mathematics from basically nothing. Have a nice day. Um, that was definitely scary. Defining the integral. Yeah. Ouch. So, I mean, I guess if that's your analysis course or logic and proof, then you've already sort of done that because it's a part of Calc 1. Doing the, like, 1B, your integral calculus. So once you start looking at that, then you say, okay, this is going to be easy enough for me to just knock this out in 5 minutes or something like that. You may have to refer back to your book because, quite frankly, I don't remember the 100% official definition of taking an integral. I know more or less what it is. I just, there are some little tiny things that maybe I forgot. So. Interesting. So is that a lot of application type stuff? No applicable. 100% theory. Nice. Yeah, so our, what I was getting at before, our logic and proof class is let's see, you have to take Calc 2 in the United States for doing our proofs class. So basically they want you to have a fair amount of understanding of how the proofs work for calculus, which includes doing all of the random little, like, integral tests and series tests and how to prove oh man, what was it? How to prove Taylor series. Cannot get through the book without logic and proof class. Yeah. Yeah, I mean, I'm over here. It's in my bag, but I'm over here. I've got 2 math books that I have been working on for an insane amount of time. Schaum's partial differential equations. As you can see here, I have gone about 10 pages maybe, and I have Not all of these pages have been written in, so, you know, this is actually an excerpt from a different book, which is a fair amount by itself. And yeah, I've only written on like 10, 5 of these pages essentially. So I'm just expecting like this is how much it's going to take me to get through a decent portion of the book, but yeah, I've gone about 10 pages. Every time I try, it's just like I can't even. I mean, like I've been doing this. I took partial differential equations. Differential equations is supposed to be like my specialty, and I'm still stuck on page 12 or something because I never took an analysis class that was really that in depth. I think it really did a disservice to me. I did myself a disservice by not taking like math analysis as a separate class. And then I did the same with I bought the book from Pavel Grinfeld? No. Yeah, Pavel Grinfeld? I gotta... Yeah, Pavel Grinfeld, tensor calculus. Like, trying to decipher any of that was no. Like, no. I did not do okay with that. But yeah, I've gotten a little bit farther through that book because um, Grinfeld is a very excellent teacher, and he speaks really well, and he also does a lot of really awesome like prose inside of his books, inside of his textbooks, and so he explains everything very clearly, and it's very nicely done. But I just got to like chapter 3, and you know, I just got backslapped because it was just like, okay, this is okay. This is really hard. But I mean, this is the sort of thing that like I need to at least try something, try to see how far I can get with it, and challenge myself on a, you know, weekly basis at least to try to do something. And really, that's the name of the game, is challenge yourself, get outside your comfort zone, do something that you're like, this is insane, I can't do this, and then keep pushing, because eventually I'm gonna get this. It's just gonna be a long time. And I need probably 3 or 4 extra resources to try to understand what all of these individual like get different perspectives on each of these. So tensor calculus, again, I could probably find, you know, 3 or 4 slightly less effective books, but they have a different perspective, and it makes me understand doing like, you know, doing a round robin between 4 of them. I could probably understand it. And then the partial differential equations, I probably need to break out my old book, which was incomprehensible 100%, but it led you from doing simple problems to doing harder problems a little bit easier than this Shams Outlines does. So I never thought that analysis was useless. I just never really took one because I was an education major, and I never had to. So it was just kind of like, eh. But yeah, topology seemed like a lot of fun, and I didn't get to take it because I decided to take all of the education classes, and then when I got to my master's program, topology was not an option for my path. Can't remember if it was actually an option at all at my school, but Romanian grammar. So there's another thing, is that I have always been really interested in linguistics, and that was my um, tertiary choice. My primary choice was physics, and then when I got to the end of physics 2, I was like, oh, I'm going to be hurting next year because I have to take thermodynamics, and it has like a 39% pass rate or something like that. And I was like, I don't know if I can cut this. And all my friend or one of my friends, we were doing a group project, and he was like, we're all just going to be teachers, right? And everybody had a good chuckle about it. And I was just kind of like, hmm. And then, physics education was going to require thermo just as well. But I really liked math. I've always liked math. I've watched Square One TV growing up on PBS and all sorts of cool stuff. So it eventually became obvious that math education was kind of like my thing. And one of the other majors that I kicked around was linguistics. I never really wanted to do like computer science or, I mean, like programming is fun and I like doing it. I do not want to study the architecture of like C++ versus the architecture of Python versus the architecture of whatever, and then be able to write stuff in assembly. Like, I don't care. I'm good. Like, there are plenty of other really so much smarter people who have got that figured out. I will very happily do whatever, like learn a brand new programming language and, do whatever I need to in that new programming language. That's why taking Python or, trying to do Python online was such a departure. It was just like, I've only really learned MATLAB and C. Yeah, so the way that we did it, our education classes, or our math classes were identical to the math majors up through sophomore year. So we took Calc 1, Calc 2, and by Calc 2 I mean like the BC stuff. Um, no idea if that means anything to you, but you have integral calculus, differential and integral calculus, which is part of Calc AB, and then the integral tactics and numerical analysis and all of that stuff belongs to Calc BC. So it's like learning how to do integrals and then applying all of them in the thousands of different ways that you can. And then we also had the proofs class and abstract algebra, multivariate calculus, and differential equations. So all three of those, the proofs class was 4. Those were 4 classes in our sophomore year alone, which we had to all take. And in doing that, that's where we broke away for education versus math. Our education classes took history of math. We took a math, what was it, like math course for teachers or something like that. And then we, for our junior year, we also had, same as the other math majors, we had abstract algebra. Maybe one more. Yeah, I don't remember what the other one was. But there was a whole list. So that's where my spouse ended up taking math analysis, was at junior level, and then I didn't do it because I was too busy doing math for teachers and math history. She was actually an education major too at one point, and then was like, no, I'm not doing this. So she only got two bachelors, one in math and one in theater, and got a minor in psychology in 5 total years. She's really good. Yes. So she had 5 years. She ended up attending. She was gonna go to like, yeah, true. She was going to go to a really fancy school, and was like valedictorian in her class and all that stuff, and got a free ride to an Ivy League. And they brought her up, and she was just like, I'm kind of really far away from home, and this sucks. I don't really like it. I want to be closer to home. I want to, have more flexibility. I want to do all this stuff. And they were like, yeah, sorry. You can, you know, it's can't really do that here because it's this particular Ivy League school was just really far away comparatively. So she went to the state school where I happened to go the next year. Um, and in her year that in her 1 year before I got there, she ended up she was majoring in psychology, and she took a bunch of classes, and then and I think she also took classes over the summer to like bring her up to speed where she would have been for 1 full year, because she like missed a part of a semester or something. Anyway, not important. But we like stories, so she ended up taking a bunch of psychology classes because that was her major, and she was like, "This isn't really working for me," and switched to math education. And then she took the one course where you visit schools in your sophomore year and try to learn how to teach through this pseudo internship where you're just basically visiting a school and hanging out with teachers. And she was like, yeah, I'm not doing this, and switched to just math. So she only wasted like one class, took all of her prerequisites, or like, gen ed and stuff like that. And then her advisor said, well, look, you're only like a class or two, I think two, away from having a minor in psychology, so you can do that. And she was like, well, that's easy, sure, I'll just knock those out. And did two classes over, another semester or break or something like that. I can't even remember. It's been like almost 20 years. So, and then she went through a bunch of theater classes and was like, I'm really excited by this. And she wanted to take stagecraft, which was like creating props and doing the set work and set design and other cool stuff like that. She was like, I want to take this class. And her advisor said, that's only for majors. And she said, all right, make me a major. And her advisor's like, you sure? She's like, yeah, I'm good. Got plenty of time for it. So she ended up double majoring in theater and pure math, and then getting her minor in psychology. Meanwhile, I barely make my math education one because I took like three or four different. I took like three or four elective classes. I was just like, I want to enjoy myself, and my advisor was pulling her hair out. She was just like, "You're not gonna make it." I'm like, "Hey, I want to enjoy my time here. I want to make sure that yes, I need my requirements, but I also have things that I want to do." So I ended up, let's see, my freshman year I did waste time because when I switched majors, I no longer needed both physics 1 and 2 and chemistry 1 and 2, which I took. So I only needed one of them in a double sequence, not both. So I kind of screwed myself over there. And then, let's see, I took German for a semester, uh, which was only the like basic German, so it didn't count for Gen Ed. Okay, so there's another semester that I wasted a class. And I took our kinesiology class in order to become an EMT because I was like, I want to be an EMT. I mean, not like professionally, but at least I want to have this knowledge. It's important to me. And, my advisor's like, okay, because it's a 6 credit class. It took up a giant chunk, 6 hours a week. It took up a giant chunk of my time, and I had to study hard. That was a difficult class. I mean, like, it's not super intensive if you know how to study, because, I'm a math major, I know how to study. But, like, knowing all the little things, and it's just such different knowledge than math. My mom was a nurse, so that kind of helped too. I had a background knowledge of a lot of like first aid and things like that, so it kind of came second nature to me. But I really had to work hard to get it. Yeah, I like her. She's pretty awesome. So like, I mean, the two of us have, between the two of us, we have a lot of knowledge that's just like random. She's got all this like theater stuff, and I just kind of enjoy theater. So I listen to, music, and I listen to show tunes and stuff like that. That was one of the first things that she noticed about me was I was when we first met, I was an RA in the same dorm where she was the treasurer. So she handles the money for the entire dorm, and then I was, one of the RAs who's like, let's figure out what to do. Let's use that money. Let's do some fun stuff. Let's do some activities. And so we sat down during the week before classes started, and all of us, the RAs, and all of them, the dorm governance committee, all got together, sat down, and like introduced each other, and then we talked about ourselves to each other, and it was really cool that we had this like couple of hours to just kind of get to know people, and she and I just hit it off kind of casually. We weren't looking for, or I wasn't looking for a relationship at the time. I was actually dating somebody else, and I said something about woo. I said something about like really liking Les Mis, having been to the Wang Theater in Boston, and gone and seen Les Mis in this humongous theater, awesome, venue. And she was like, "Oh, you like show tunes, do you?" And I was like, "Yeah, it's really cool." And I can't remember what else it was. Oh, like I like math, and she was like, "Oh yeah, I'm majoring in math too." And then we get to like five different areas where we're just like 100% in line with each other and our interests, and you know and then I was like, yeah, my girlfriend, da 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 da, and she was like, oh. But that relationship did not work out too well, and this one is uh, just wonderful. Oh, and puzzles, man. Let me tell you. At some point, I really want to get on stream with some puzzles from somewhere. I got to figure it out. I got to figure out what the permissions are for this. But yeah, there's some really cool puzzle hunt type stuff that I've been doing for years now, where none of them are mine. So I mean, that's my problem, is that I would need to get permission from the actual creators to actually stream it. But yeah, this stuff is intense, and we spend like we spend full days just out and doing puzzles and walking around a town somewhere. We It's absolutely just a wonderful day, and we have friends that are in the same stuff. Uh, we all have. We went from being like single people who could do this all day to then people with kids who could like do the puzzles, but at the same time, it's going to be casual because we got kids to take care of and drag around with us. So like we're not quite as invested, I suppose, as we used to be, where we can't just like do the puzzles all day. We gotta focus on the kids and then come back and be like, you get 13? Yeah, okay, cool. That's really rough when it's like you have an hour to do this puzzle. Good luck. And like one of us will do it and the other one will be sitting off to the side doing stuff with the kids, and then we'll kind of like peek over and be like, yeah, all right, I have no idea what you're doing. It's cool. So I would say like don't limit your scope. I part of part of how I got interested in so much other random stuff was that I constantly listen to music. I mean, you can hear it in the background. Like this isn't quite my style, but like it's pretty cool, and it's free, so kind of take what you can get with Pretzel Rocks. Um, I should just change this to just chatting. Um, yeah, and that's really the thing is you got to be as happy as you can be, trying to just do stuff, have fun, work on a problem. Pick up a problem, look at it, pick it up, turn it around a bit, do a whole bunch of pages of work, figure out if there's anybody else who's working on it, but at the same time, like if it's making you miserable, just don't do it. Just step away. Maybe not forever, but yeah. And I had much the same ideology. Like I was a pretty solid B student throughout high school, most of college, with the exception of when I got mono. Whoa. Um, but yeah, I never like strove to be the absolute best at anything. Like I actually have now carved out a little niche, which is weird, but it works. Um, yeah, that's the other thing is if you just kind of relegate kids to statistics or things like that, then it can cause potential I mean, not problems, but it'll make people unhappy. And yeah, like you said, it's just why would you want to do that to people? There are some people who do need, like, have that need, that drive to be the absolute best. Yeah, and so really the whole point behind like liberal education generally is not I will say, not politically conservative liberal, but rather it is this idea that everybody should at least have an appreciation for all sectors of knowledge. And not forcing somebody to pick, like, once and forever, you will choose what do you want to do and you will study nothing else. Like, that is a very conservative education, and it doesn't really serve people because people can change their mind. People can discover something that in a liberal education you go through and take like 50 different classes. I mean, not 50, but you take, 10 different classes in completely different areas. You talk about things with people that are from completely different sectors, and then suddenly something sparks in your mind and you go, that, what is that? And you do your own research and you start building your knowledge around this thing. I mean, this is what, like, my YouTube history would show. If I actually allowed anybody into my YouTube history, it has, like, I've got so much stuff in there from so many different creators who do all sorts of different stuff. I mean, yes, a lot of it is educational based-ish, but there's, people from all different sectors. I try to learn as much as I can about, like, everything. And I mean, yes, it is true that uh, my particular, I mean, the name of this channel, again, and Simplex Pachinko, comes from this idea of trying to learn more about Pascal's triangle and then expanding it into 3 dimensions and then starting to say, like, what if we went further? So yeah, and that's another interesting thing that you bring up. I've also seen that video in my recommendations. Um, and the other interesting thing about that is I worked for an insurance company credentialing radiologists. So, like, going through all of their. This was before I got my job at this college, was that I was going through a huge database and sifting through all of these files that these radiologists had and making sure that they actually had the rights to work everywhere that they said they could. So it wasn't even all that much insanity. I mean, it is a little bit. But even if we had a nationalized healthcare system, about 60% of that work would be identically the same. Because we would have to take all of the information from the provider's file and put it into a database. And then, I mean, granted, it would be on like a national scale instead of for one company, but and then the other job that I had, or that I got offered at the same time, roughly speaking, as when I got my job at the college, was to join that insurance company's fraud detection department because I had also been working with neural networks. The lady who did the interview was very interested in the fact that I had done neural networks as part of my master's. She was like, oh, I see. So you've done data mining and you've done neural networks. This could be very helpful for what we do. So, at one point in my life, I could very well have steered off in that direction and done something completely different. Yeah, and I loved the class that I took. It was very much math oriented rather than like practical oriented. I mean, it was somewhat practically oriented, but it wasn't like, here's how to build a neural network. Now let's do that. It was like, here's the mathematical structure behind the neural network, and now you're going to go off and attempt to build one that does this, or one of this particular style. So build a Cohonan network in order to accept, inputs from an RGB system that then outputs something else. You know, outputs an RGB value according to some plan. And so you had to create some sort of, you know, create a Cajon network that input basically RGB values for a pixel, and then it output a different RGB value for that same pixel. How you built most of the stuff in programming in CS, yeah. This was also the professor who, during our midterm and again at the final exam, was like, okay, so here's how you need to do this. You need to read through every single question all the way through the entire exam before you even start. Then go through and make notes on all of them, and then start working on all of them individually, but do not stop. If you have to think, move. Turn the page. Go to the next problem. And I was I looked at the first page of my exam, and I started reading through all 10-ish problems, whatever it was, and I started getting a little bit like choked up, and I'm like, I'm going to fail this exam. Like, I am going to fail this exam. And I followed his instructions. I went through all, 10, 12 problems, whatever, read all of them, fully absorbed it, and said, okay, I just need to calm myself down. And then I went back and I was like, nope, still don't remember. Okay, here's a little thing, but don't remember much. Toss it. Keep going. And then go back to the beginning and start over. And as I went through, it was probably about a half an hour into the full exam. I had notes on every single page, and I had done probably 2 or 3 of the easier type problems that I remembered how to do. And I was like, huh. So this is actually a neural network hack for your brain, is you want to start warming it up on all of these individual exam problems. So read through your exams as far as you can. Read through all questions. Then go back, make notes. Then go back and start working. So I've told all of my students since I started teaching, I have told all of my students, you should do this, and it's going to help you. Like, it helped me, it will help you. And, fair amount of them listen to me, and do pretty well. I won't say very well, but, Yeah, see, you already had it built in. So, one way or another, you already knew that this was what you were supposed to do. Or, right, at least just look at all the questions, regardless of whether or not you make notes. But this is true, no matter what the subject is, too. It doesn't have to be math. Yep. Yeah, with a biology test. It can be history, English, you name it. Or, well, in your case, Romanian. Whatever essay you're trying to create, do the same thing. Read through every single thing, and then 9 out of 10. Yeah. Yeah, that actually, on that exam, my final exam for neural networks, I ended up getting an 85 or something like that, and I thought I was going to get a 50 on, yep. I thought I was completely screwed, and then ended up with an 85 because, again, his way of doing this really kind of saved me. Otherwise, I would have like gotten stuck on number one, moved on to number two, sat there for 10, 20 minutes just thinking about it, and then moved on to number three. And then every time you flip the page, you're cold. You're coming back to that individual question cold. You hadn't seen it before. Ochem. Yeah, I had some friends who, um, or my parents had friends that they met at our. This is weird. Um, so like this lady was their uh, server at this pub, and my dad got to talking with her because she's just like this very chipper kind of California girl, talking like this. Oh my God, you guys, and she she's just super happy about everything. She's like, oh yeah, I'm doing my master's at this school, and he's like, oh really? What's your master's in? And she's like, molecular biology, and he's like, what? I thought you were going to say business administration or one of the other 50 majors that are more likely for somebody who sounds kind of maybe a little ditzy. But yeah, she was like molecular biology. So her husband, maybe fiance at the time, was also doing his master's, also at the same school in organic chemistry. And a couple years after that, I was starting to, kind of look into schools. I think this was sophomore year of high school. So, I had like another year before I was going to start really prepping. And they decided to send me for one day to shadow both of them and say, like, what is it that you do here at the college? And let's start asking some questions about like cool stuff. And so we spent, me and my brother, who's 3 years younger than me, um, spent the morning with Matt, the fiance, who did OChem, and he talked about his research, which was into chirality. Specifically, he was talking about like the chirality of acetaminophen. Hmm, wait, no, aspirin. The chirality of aspirin, which naturally only grows with one chirality, but when we produce it, it um, gets produced in roughly 50-50 quantities of proper chirality and opposite chirality. And so you have to like isolate the improper chirality and destroy them. It doesn't actually do anything, that particular molecule, but there are also some other molecules which like are toxic if they come in contact with the human digestive system, for instance, and they're the wrong chirality. That was, for instance, thalidomide, the what was that? Anti-nausea drug that was made for women with morning sickness. Um, when produced naturally, thalidomide is only one chirality and ends up just being fine. But when you have a 50-50 mix, as in the artificial type, then it caused all sorts of birth defects and horrible, horrible problems. So women who used thalidomide that was created artificially in a lab ended up getting, again, 50-50 roughly left and right chirality, and it ended up causing birth defects and abortions and spontaneous abortions. It was just like, and this is for women who wanted to have children. Like, this was not acceptable. So he was doing some studies on chirality of various organic chemistry. Yeah, and what he had explained to us was, here's how to do, or here's how to look at stuff, and he talked with us about aspirin. So that was a really interesting talk. And then we had, did the morning with him, went to lunch with the both of them, just downtown at some restaurant, and then went with Julie over to the uh, molecular biology lab, and we did plates. So we made agar plates of bubonic plague. Here I am, 14 years old. Just think. So basically, we were, taking something from a sample, and then scratching it onto agar plate, and then sealing them up, putting it into an incubator, and then 3 days later or something like that, she had us come back to the lab and say like, "Hey, here's your sample. Let's take a look at it under the microscope." Yeah, yeah, yeah. I mean, keep in mind, right? She knew all of the proper lab procedures. She was a grad student. She had been teaching this particular lab to 18-year-olds. And, we signed a waiver, so it was fine. But, all proper lab procedures are handled. And my brother was 11, so you can figure that one out. Um, But yeah, it was great. So we scratched out agar plates, and then the proper lab procedure is, you've got this little miniature incinerator that you have right next to you. It looks like a pencil sharpener, basically, and you stick your the little scratch stick, whatever you got. It's a little wire with a loop on the end. You just like grab a little bit of the sample and then scratch it into the plates. So you stick it into a little insanely hot pencil sharpener and burn the remaining sample that was on it. It was pretty cool. All right, hang on a minute. Anyway, yeah, my parents both signed on to this. They knew that this was going to be something interesting and fun. So it was, the summer before I turned 15, I guess. Or wait, no. It was in the summer. Probably before my junior year. So I guess I was 16, my brother was 13. But, you know, roughly same difference. Still, it would seem very young to be handling bubonic plague samples, yeah. But if I'm honest, bubonic plague was like the least dangerous thing that we potentially could work on because like they had containment procedures. It was fine. It wasn't like we were doing Ebola or uh, what was big then? Oh man, I don't even remember. Well, I mean there were some. I guess anthrax was another big one that was going on roughly at the same time. Yeah, and it's not like we actually had like I guess at that time this was not super dangerous, right? I mean Ebola was, but um, bubonic plague was not particularly dangerous. So basically all we had to do was like we just had the plate in our bare hands and did the little scratch thing, transferred some sample over, sealed it up, put put them in the put them in a pile, and then put the pile in the incubator. And then once we had labeled everything and stuff like that, the first thing you do is wash your hands. So there's that gone. And you scrub probably a little bit past the wrists. That's all you needed. It wasn't like a huge deal. And yeah, we didn't. I think at that point we didn't even have like we might have had smocks, but I don't remember having like full lab gear. I think it was just like a regular lab coat and goggles. But that's 1990 something for you. And again, bubonic plague, not typically dangerous as long as you're not being an idiot about it. Oh, my eye itches. Let me put down the sample and itch my eye right now. If anybody else out there wants to get a word in edgeways, feel free to interrupt. Come on in, we'll talk. So to anybody new who might have just come in, I am Obi-Wan Pez. This is N Simplex Pachinko. My Wednesday night math streams are typically on all things mathematical, but uh, feel free to post any sort of homework help problems. If you need me to, or would like me to cover a topic, please feel free to drop something into the chat, and we will try and help you out in terms of getting you to truly understand what is going on with that particular subject. As such, I may or may not answer your question directly. I will most likely not say, here's the answer to the problem you're working on, but we'll try to get you to understand a slightly more deep, get you to have a slightly more deep understanding of what is there. So, if you have any questions, feel free to ask. I also have an email address, which is nsimplexpachinko@gmail.com, and that is going to be my my place for anything that you would like to, ask ahead of time that I might need to research or anything like that. I am a math teacher in the Mid-Atlantic region at a small college, and I do pretty much everything from basic, intro level mathematics and developmental stuff all the way up through differential equations. Like Algebra 1. Like, Okay, so we also have yeah. I don't necessarily want you to buy something. So I have a book that I like, or I have an author that I like named Harold Jacobs. Unfortunately, his books are kind of expensive. Um, not publisher expensive, but they're like $30 to $50 a piece. No, that's more than that. $50 to $75 a piece, I think, for something that covers high school level algebra, geometry. He did a couple of other like general math sort of things. Shh. Well, that's the other interesting thing is we used to have friends who would go back to India for breaks, and they would take book orders from all of us, because in India they get a, what is it called, overseas edition or something like that, which was paperback and cost like $30 each instead of ours, which were like several $100s each. Oh, yeah, yeah. Yeah, our hotels here in the States, $100 a night gets you like, yeah, yeah. Hmm. Yeah, mathematics a human endeavor. Um, and he also has elementary algebra and geometry. Hmm. Oh, he passed away. When was that? Oh, 2020. Not too long ago. I exchanged emails with him when I first bought his books in 2005. So he was 72-ish and still, corresponding with people. Yeah. I ended up buying a bill from the Republic of Tanzania back when their bank was collapsing, and or rather after their bank had already collapsed. Some entrepreneurial type person bought a whole bunch of their money for really cheap and then started selling the individual bills for about $5 a piece, which meant that there was like a 5 million times upcharge for the for that individual bill. I forget what the yeah, there was some what was it? I don't remember what it is now because it's sitting in my office at school, but it's like I have a bill that has like it was while their bank was collapsing, they were starting to print higher and higher designated notes, and this one's like 5 billion or something like that. So I have a note that says like 5 billion on it, and I was just like, I have to buy that because that is insane. That there was this massive, massive instantaneous inflation. And it could potentially be fake, but somehow I don't think so. Really? Oh, forget when they're from. That's the other problem. Is that like... Anyway. Yeah, so, I don't really have a potentially good book for like E2 edition 2, like second edition. Two E would be second edition. Oh, no, it wasn't Tanzania, it was Zimbabwe. Yep, that was it. It was the 2008 $10 billion note from the Reserve Bank of Zimbabwe. Their bank was collapsing, and they had printed these ridiculously high denomination numbers, or notes. And it was a really horrible situation. And yeah, there's 100 billion special agro check, which looks like it's from like a business. You have to agriculture. I don't know. So I occasionally show off that I'm a billionaire. Of course, it doesn't actually count anymore because this money is now worth one souvenir. It is not. It is not worth any amount of money to anyone in the entire world, and it's kind of an interesting exercise just by itself to say, like, you know, what is this money really worth? What is any money really worth? And it's only worth what other people will accept, what other people will negotiate it for. And I mean, that's true for any amount of any money anywhere in the world. Yeah, so this is the actual... I'm going to drop it in chat here. Ugh. Why would you do that? Okay. Ew, why? There. Okay, question. Can I just eliminate all this crap? Yes. Okay. Hate URLs that have 50,000 bits of tracking numbers. Oops. Ah, damn it. Alright, hang on. That. Yeah. Now, I do not recommend buying this. Because again, it is worth one souvenir. It is worth $5 to the person who is selling it. And anybody who will buy it. But yeah, me personally, I will spend $5 on something like this, where it is a piece of history that is, to me, something which will serve as a teachable moment to many different people. Money is only what everybody else says it's worth, and you really have to be careful when you start talking big numbers. This inflation of getting up to the 10 billion range, like, that's not going to help anybody. Yeah. So anyway, I spoke with Harold Jacobs over email, and oh yeah, right. He was very interesting. Uh, hmm. Nope, that wasn't him. Harold Jacobs, math. Let's try that. Um, hmm. He was born in 1939, and I don't actually see his. I don't see a death date here, so okay, maybe this Harold Jacobs is still alive? Question mark. Okay. um, yeah, 1939, so 83. Okay, 82. I do math, I promise. Yeah. Geometry, seeing, doing, understanding, elementary algebra, and mathematics: a human endeavor. A textbook for those who think they don't like the subject. If there's a chapter in the Stewart book with a U substitution and fundamental theorem of calculus, yeah, if you're already comfortable with that, I would say skip it, or at the very least, give it a quick browse to see if there's anything new. Obviously not new in the sense that like you didn't understand it before, but new in the sense that you might have a different perspective on it. Just so fundamental theorem of calculus comes back occasionally through the rest of your classes. So not just Calc and Calc 2, but also like Calc 3, differential equations, and maybe linear algebra, depending on what's going on and how your teacher's explaining it. Mostly Calc 3 and differential equations, though. It will come back, and it is, yeah, it is kind of understanding, or kind of important to have a basic understanding of what it is, but and the new thing that you can do with it. So at various points, the fundamental theorem of calculus is going to do something like, let's take the integral from 0 to x of f of t dt, and then we're going to take the integral or derivative with respect to t based on that. And this is actually equal to just f of x. Right, because when you're taking the derivative, you're going to have something that is evaluated at a constant. And when it's evaluated at a constant, you take the derivative, it's 0. So it just eliminates itself automatically. And then evaluated at x, now it's evaluated on a variable. So then you're taking the integral, but you're also taking the same derivative with respect to... Maybe that is x. Hang on. Arg. It's been far too long since... Fundamental theorem of calculus. Yeah, it is dx. Okay. d dx. I was going to say, because when you evaluate this at x, it becomes a function of x. So d dx like that. Right, and then the corollary of this is you've got the integral from 0 to x of f of t dt. This is going to end up being big F at x minus big F at 0. And this is called the displacement. So how far has something traveled from the initial value where t equals 0 out to some value where t equals x? And x could be any number you want. So that distance, capital F of x minus capital F at 0, gets you your displacement. And that's just one step away from the fundamental theorem of calculus. All right. Got about 20 more minutes if anybody wants to get any other questions in. Um, or, Kiwi Gamer, we can keep talking about it all night. It's okay. Let's see. There's some other stuff that we use the fundamental theorem of calculus for in differential equations, and I can't think of it off the top of my head. Useful. But basically that has a lot of the same... Oh, got caught. Also, fundamental theorem of algebra is in here. 228. I think the fundamental theorem of calculus would actually be in that differential equations book, given that we're doing calculus. Is this just the number of zeros for... Yeah, characteristic. Okay. So basically, learning the exact same type of questions that are going to be on the exam. Yeah, so as a teacher, I hate that. Right, and whenever my students are like, what are we going to have on the exam? I'm like, all right, look, if you can't figure that out for yourself, like read read the entire chapter. If you can do everything in there, great. Yeah. Yeah, it was my junior year. I was doing trig, and we got to, well, calculus. We got to the point where we were doing change of base formula for logs, and I ended up proving the change of base formula in class, like just over in the side of my notebook. I proved it, and I went up after class and I was like, "So is this the proof that the change of base formula works?" And she was like, "Yes, and I want you to show that next class." So I get called up during next class, and I showed everybody the proof of how it worked, and I was like, "This is just like, I thought it was amazing." And a couple of people were like, "Hey, good job," and everybody else is like, "Man, overachiever." But like, I'm not. So then the exam rolls around, and question 8, I get to question 8, and it is prove the change of base formula. And I look up at the teacher, and she goes, like, I gotcha. It's like I got a 97 on that whole exam, and got 100% on that one question. I always did my homework, but I absolutely hated the projects that we did in that particular class, especially. She was. I had this absolute love-hate relationship with this lady, um, professionally speaking. But yeah, she pushed us really hard to do stuff, and I can sort of appreciate it now. But in the moment, I was so angry with her about everything that she did, because I was just like, "You're not. It doesn't." It, so her project was, let's see, we had one in the first semester where you had to, you were a financial consultant, and you were going to tell this person when they should retire and what kind of like payment plan they should do to put into their retirement portfolio. Now you're only going to be earning a certain amount of money, in the first few years of your career, and then as you get older, your um, income is going to start expanding somewhat. And like, we were encouraged to just play around a bit and see what you can get. The goal was to have $1 million by age 65, so that the person could, in theory, retire somewhat comfortably and not have to worry about it. We'll see how that goes. Um, yeah. So anyway, uh, so then we had to. There was a whole list of questions that we had to sort of answer going through. That one was actually pretty easy. Yeah, but so we didn't have to do calculus. This was a pre-calc class, so we were actually suggested to do. You could actually do it using the amortization formula, which you could find in the book in a section we never went to. So like amortization and like regular payment could be done using this particular formula. We never touched it. We never even looked at that portion of the book, but it was there. So if anyone went and used that formula, they would get like almost instantaneously full marks. And they'd have to explain it, but they would be able to get full marks by using that formula because you did your own research. You went out and you did that. But the way that most of us earned our scores, which could have been full marks, but of course, we're teenagers and we can't explain anything. Um, no offense. Uh, is that we created a giant spreadsheet and just said, okay, I'm going to pay in $1,000 every year for my entire life. And the idea was, what happens if you start at age 25? So, you're out of college a couple of years, you got a career going. Can you put down a little bit less than $100 a month into this retirement account? And it adds up to $1,000 a year, or $1,200 if you just wanted to go an even $100 a month. And then do a spreadsheet, so fill down, and then have the sum over on the side. And then what's the total? So what is the total amount of money that this person would have starting at age 25, going to 65? Okay, well, just for the amount of money that they collected, that's easy, right? The amount of money that they paid in is going to be 1,000 or maybe 1,200 times the number of years that there are. Again, on a spreadsheet, this is nice and easy. You just select and then hit sum. Or put a formula down there, equals sum parentheses this range. And that was pretty easy to do. And then it was also like, okay, now this is the amount they paid in. How much would they get if this was the terms and conditions on their account that they have? So it's like a 1.5% compounded quarterly, something like that. So figure it out. And again, it's easy once you know the formulas. You just plug it into Excel and it just goes. um, and again, there were a bunch of questions about, what's happening at each stage. Why is it adding up interest as we go across? Like, why aren't you just doing this all at once? Again, we couldn't find a formula anywhere. At least none of us could. I think there was one guy in particular. There were 3 or 4 really smart people, like hyper smart beyond the level of comprehension of any of us. They went to Caltech, they went to MIT, they went to Harvard. They went to these big Ivy League schools. They were numbers 1 through 5 in the class. All that stuff. Those people were able to do their own research and find, here's the equation you need, by the way. And then, didn't really share it with the rest of us, but that's fine. It didn't matter. And then the second project that we did was the much harder one. It was based on trig, and it was you have a cuckoo clock that is ticking away the seconds, and then at some point, what happens with a cuckoo clock is when the weight reaches the bottommost position, there's a little ring on the other end of the chain. The weight just provides a constant downward force, which allows the entire mechanism inside the clock to run. So cuckoo clocks essentially run on gravity. And, grandfather clocks and all these other ones too. You have to then wind the clock by pulling on the chain until the weight reaches a higher position, and then you have gravitational potential energy that is then winding, that has wound the clock. At some point, the ring reaches the top position, and the mechanism unhinges, and so it releases the pendulum. The pendulum then swings, but it eventually reaches a bottom position. So this is a damped pendulum. It is essentially a cosine function that is bound, or a sine function, I guess, bounded by exponential functions. So it's like e to the x times sine of x. And it's bounded by e to the x and negative e to the x. So it got, an upper and a lower bound, and then it continues on like that. And the idea was to find the particular function for this particular cuckoo clock given all of this information. You know, it took, I don't know, each swing of the pendulum was like 3/10 of a second from one side to the other. So then total ends up being, you know, 0.6 seconds. So work out that ends up being inside of the trig function, and then you've got all these other pieces doing transformations. Now, I've talked about transformations on this channel, so like it would actually be kind of easy to do that now, but so many of us were so angry at that time, just like I don't know how to do this. Like, and she said, like, you're not allowed to use calculus. And of the two hyper smart people that were like really far ahead, two of them ended up using calculus to solve this whole thing. One of them got an A and one of them got a C, and we were like, hang on a second. How did that happen? And it ended up being like, you know, the one guy who got a C ended up not showing his work at all. But we couldn't understand that. We're teenagers. And they're like, oh, because we hadn't learned calculus. And so by looking it up, he might have been getting help from his parent or something like that instead of actually doing the research himself, which, I mean, that's nonsense. But again, the one guy who didn't show his work, like, probably should have known better, especially with the other project that we had just done. Well, because we were trying to show what she was really trying to do, and of course, again, none of us understood this, is that she's trying to get us to understand that this damped pendulum that's going to go like this forever and ever, again, shrink down as exponential. No, so we don't need the squeeze theorem. What we needed was that this was going to create a series of maxima and minima, the x values of which, or the t values of which, would allow us to find, you know, your delta t here is going to end up being this sine times the b value here. So A, E, sine B times the quantity T minus C, all plus D at the end. We ended up with, this was a 0 because it's eventually shrinking down to 0. So that's easy enough. The C value would tell you where did this thing let go. So it reached a maximum when it finally let go. So really what we'd want to do is actually use a cosine, and then we don't have a C value at all. It's a 0. B is going to be that's B equals 2 pi over the period. And again, that's delta t. So that's going to be 2 pi over delta t, whatever that was. Again, 0.6 seconds or whatever. That number would go down there. And then A would end up being the like initial amplitude. So whatever the initial amplitude was, which would have been at t equals 0. So since this is the maximum possible value, this would have gotten us the amplitude, which then would be altered by this e to the negative x term, or e to the negative t term. So this is going to be c, d, e, whatever, n. I don't want n, because it could be any value. Like alpha t. All right, so then how do we do this? Well, we figured out A because that's the amplitude from before. B was given by this stuff. No C, no D. It's a cosine because, again, we're starting at the maximum value. And then the alpha would be found from figuring out the multiplier from one maximum to the next. And again, all of them should be the same, going all the way across. So if it was data, for instance, like you had a bunch of data, I don't remember how it was done, but if you had a bunch of data, you would have to look at this and say, okay, from this one to this one, here's the ratio. From this one to this one, here's the ratio. From this one to this one, here's the ratio. And then just keep doing that over and over again for all of your data. And then whatever your approximate value is going to be, you just be like, all right, there it is. There is the other possibility that if you have all that data, you could also make every possible combination of connection. So this becomes a combinatorial problem, essentially, where you're going to say, okay, it's going to be like a statistical average of all of the maxima compared to each other. And you'd say, like, if I'm going 2 down to this one, then it would be the square root of this ratio between here and here, or the cube root between here and here, or the fourth root between here and here, or the fifth root between here and here. And again, take the statistical average of all of them. But then again, you probably also have to do the minima. And then if you want to make it more accurate, you could probably do all of the... Oh, no, that doesn't work. Never mind. Y values. Right. You could do all the maxima. You could do all the minima. And then get a statistical average based on all those. I wouldn't waste that kind of time. I'd probably just look at all the maxima and say, here's the ratios between all successive maxima, and then take the statistical average of those. If it isn't, in fact, data, if she, for instance, gave us just the first one, so it went from an amplitude of here to here, or amplitude, if the swing decreased from this value to this value, then I'm going to do, like, alpha is, or no, so e to the negative alpha 0 is going to be 1. That's not really helpful. Or a. Yeah. Alpha, and this is t1 equals, some number here. Then we've got to solve for alpha in here. So whatever this ends up being, some measurement. Swing. Let's go S. Right, so this is going to be S over A. Then we're going to take the natural log. That's going to be negative alpha over, or alpha T1. So then this is going to be over negative T1 is equal to alpha. So to get alpha, this is how we do it. So me now, this is simple. This is this is really ridiculously easy. Me then, I was just angry because I'm like, you didn't teach us how to do this. This wasn't like... Yeah, no, I got you. So yeah, I mean, if this was, 6 centimeter deviation, and this one was a, I don't know, 3.2 centimeter deviation, then if that was all the information that was given us, then all we'd have to do is go over here and say, like, okay, if delta t is equal to 0.6 seconds, and the deviation changed from this amount to this amount, then and this is after 1, alpha will be equal to the natural log of s was 3.2 over 6 all over negative 0.6 for that. That's all you need to do. Like I said, this is insanely easy now that I know this. You know, now that I'm thinking about it from this older mathematician perspective. But of course, I didn't know it then. I was just upset. Alright, so that's going to be 1.6 over 3. Natural log of 1.6 over 3. And take that negative there, that can go backwards. That's going to be a 3 over 1.6, all divided by 0.6. And then we can find that pretty easily, provided I don't hurt myself here. Alright, take natural log of 3 divided by 1.6, parentheses over 0.6. Alright, that's about 1.04. 768. And then there's more stuff after that, but again, just say, well, whatever, it's close enough. So then the entire function that we had here, f of t, now keep in mind, I just did this in less than 5 minutes as to what, you know, compared to me complaining about it for weeks on end when we were doing it. This would be 6 e to the negative 1.04768t. And this is going to be an approximation, but close enough. Times the cosine of 2 pi over 0.6. It's going to be 10.47197 t. Right? Yeah. That's it. Nice and easy. No, I will say that I only just realized this within the span of me talking to you just now. Like, that it was this easy, and we could do it in no time at all. I was thinking when I started doing this out, like, oh no, I'm not going to be able to do this. You know, it's going to take me like hours to figure this out. No, I've done this plenty of times in my classes. All you need is a basic transformation of a cosine or sine function. Doesn't matter which one. All that really matters is knowing what the initial position is. And, like, when does the mechanism actually let go? If it let go, for instance, down here somewhere, and this was our t equals 0 down here, then you just have to figure out, like, what the deviation is from the top, or what the deviation is from the midpoint here. From the midpoint, that's a sine function. From the top, that's a cosine function. And then that affects your c value in here. The d value, one would hope that it's going to always be 0, because we're saying, what is the deviation from the bottom? So it's going one way or the other like this. You could, in theory, say, like, you know, the minimum here is going to be 0 or something. Your other side, don't do that to yourself. You don't want this. All right. Right, gravity is going to dictate where the 0 is for this thing. It's the easiest way to describe all of the motion that's going on. 0 is the gravitational default. And then from there, deviation from it can be in the positive and negative direction. But the idea was basically here that the cosine function is just going to be a transformation, like I've talked about many, many times before, where you're going to have this cosine function, which, you know, normally your cuckoo clock swings back and forth like not like this, but much cleaner, like a cosine function, and it always has the exact same amplitude every single time. And then at each of these measurements, we have time values that go with those particular time measurements. So this is one period is going to be 0.6 seconds. Another period here is going to be another 0.6 seconds. Another period here is going to be another 0.6 seconds. So that is constant going all the way across. Now you know what B is, because again, your period stays the same, so that means that your delta t is the same going all the way. And then it is bounded by this exponential function, which has a decay to it. So e to the negative alpha t is going to get you a decay to it. And then when you plug this all in, or plug in values, again, 0, comma a and t1, comma s were the two that we had. Here I said t0, comma 6 and t1, or 0.6, comma 3.2 were going to be our 2 points for this. It's not actually that hard. And again, I kind of curse myself now that I was whining so much. So yeah, the projects that we get into with most of our are college level / the classes you could take in high school. You know, all of those classes. Our projects are similar to this. I mean, not quite as involved, but you know, a series of questions that ask you, do you really understand the material as well as what's being asked of you? Which is why she didn't want calculus being used for the thing. Yeah, do you really understand the material? Can you answer a series of questions that have to do with this thing? Can you write at all? Not 100%, you know, being demanded of you, but you need to be able to at least talk about what you're doing. Video course on integral calculus. So like if you're thinking about just doing individual like a la carte sort of things, then yeah, you know, go for whoever it is that you really like, or branch out and find some other people. That's fine too. You know, go find some videos online that'll help you understand in whatever way you need them to. And if it's frustrating you, you could just move on to somebody else. I just heard about Outlier. I mean, not just, but like a couple months ago, I heard about Outlier, which is basically the same as Masterclass, or it's the same company, but under Outlier, you're able to potentially earn college credit by taking you are taking the class online, but the videos that are being made are made by like 4 calculus teachers across the world. 3 calculus teachers across the world. One of whom is Hannah Fry, who has been on Numberphile several times. Oh, yeah. Is it like toward the end of the chapter they tell you all sorts of stuff that you could do? I mean, it might be worth giving a couple of them a shot. Just see if, you know, see if it's something that would be at all within the realm of possibility. And if it's not working, you know, there's here. We could talk about it. Might want to give you some heads up, I guess. Alright, so I think it's getting to be about that time, unfortunately. Ooh, boss lady's on early tonight. Let's see. Yep, you too. Thank you for coming again. And we'll see if we can get some more people in. Um, if not tonight, then definitely we're going to have more people in. Doing the my next game that I'm working on, I have already done 2 sessions of it, is called Heaven's Vault, and it is a linguistics puzzle game. So, like, per our discussion earlier, that's pretty much my kind of game. You're trying to figure out a linguistic puzzle, which also unlocks certain areas that you can go to, and certain missions that you go on throughout the entire game. It is also exploration based and all sorts of cool stuff like that. So if you're interested, you can take a watch or take a whatever. Yeah, you can watch the other 2 sessions that I've done so far, or keep it on fast forward in the background, whatever. Um, and I will most likely be doing that on Friday as well. So I am going to raid Jason Charles Miller, who is the usual raid recipient for Wednesday nights. Miller's Music, nope, Whatever You Want Wednesdays is going to be what he's got going right now. The Miller's Chillers are a great group of nice, relaxed people. And we'll head on over there now. So, again, Kiwi Gamer Romania, thank you for coming. Thank you for everybody else who comes on VODs or even just stops in for a couple minutes here and there. Really appreciate it. And lurk, follow, whatever you want to do. I am eventually going to try for affiliate. So I don't know how that's going to go. But we are up to 47 followers, and that's pretty awesome. So thank you, everybody, for helping out with that. I'm really looking forward to maybe being able to put forward more math streams and, gaming whenever I feel like it. But that's secondary. All right. Have a good week, everybody. I'll see you on Friday, hopefully. And this is Obi-Wan Pez for N Simplex Pachinko. Have a good night.